Welcome back to Math with Rhyme or Reason. Today I'm going to start a series on radicals and on radical math. So we're going to start with a review again of Math 10 and simplifying radicals, and then we'll move into multiplying and adding and subtracting them, and then we'll end with solving radical equations. So today let's do a little bit of review first off with just radical math. So we're going to start by simplifying radicals, or writing things in simplest radical form. So I'm going to start with square root of 72. All right, so usually when I am simplifying radicals, what I do is prime factorize. So 72 is 6 times 6 times 2. Of course, 6 is not prime, so we're going to write it as 6 times 6 times 2. All right, so when I talk about simplifying radicals, an analogy that a friend of mine gave me was, pretend all your numbers are in jail, and the one thing you want to do when you're in jail is get out. Numbers are very exclusive, so they only talk to numbers that are the same as themselves. For example, 3s will talk to 3s, 2s will talk to 2s, and so on. But 2s won't talk to 3s. So in order to break out of jail, you need a friend to help you collaborate. So the 3s can plan together to get out of jail. So 1 is able to escape. While that guy was helping him, he got caught, so he can't get out of jail. The 2s also can collaborate. 1 will get out of jail. 1 doesn't make it. All right. Anyone that gets out of jail can multiply. Anyone inside of jail can multiply. So the 3 and the 2 that got out multiply to 6. And this 2 is still left in jail. And so you end up with simplest radical form being 6 root 2. I'm going to do another example. Let's do square root of 45. So again, I'm going to prime factorize 45, which is 9 times 5. 9 is 3 times 3. Okay. Again, 1 3 can collaborate with the other one to get one of them out of jail. The 5 has nobody to collaborate with, so he stays in jail. You end up with a 3 outside and a 5 still in jail. Okay. If there's a number out front, then the number out front would multiply with whatever's got out of jail. So for example, if number 2, instead of having root 45, we had 1/3 times root 45, then same as before, I'm going to prime factorize 45. Okay, the 3 that gets out of jail can multiply with the 1/3 that's already out of jail. So you would have 1/3 times the 3, and then the 5 is still in jail. So the 3 times the 1/3 is 1. And of course, you don't have to write the 1. You can just say the square root of 5, because 1 times square root of 5 is square root of 5. Okay. The other thing that you talked about in grade 10 was what I call high security jail. So if we change, I'm going to go back to our first example here. I'll label it number 4. But now instead of the square root of 72, I'm going to use the cube root of 72. So I'm still going to prime factorize like I did in the previous example. Oh, this is example 4. Sorry about that. Okay, so we still have 3 times 2 times 3 times 2 times 2. All right, but this number out front tells us how many of one number we need to collaborate to get 1 out of jail. So if this is a 3, I need 3 2s or 3 3s or 3 4s for 4s aren't prime, sorry, 3 5s, to get one of them out of jail. So in this case, I can get a 2 out. These 2 2s don't make it. But there's only 2 3s. So the 3s can't get out of jail. So the 2 got out of jail. Don't forget to tell what kind of jail that is. That's high security. That 3 has to come with it, otherwise you're incorrect, all right? And then the 3 times 3 that's still in jail, so that's 9. And your simplest radical form, okay? And again, if you have a number out front, then it would multiply by whatever is there. So for example, if we took out a 1/4 times, sorry, if there was a 1/4 times the cube root of 72. All right, so I'm going to prime factorize again, do everything the same. Then what happens is, so we'll have 1/4 times the cube root of 3 times 2 times 3 times 2 times 2. Okay, and again, the 2 breaks out. These 2 don't make it. All right, so the 2 that breaks out multiplies with the 1/4 that's out already. Times the 2. And this is still cube root of 9. So the 2 times 1/4 is 1/2. And cube root 9. Again, don't forget to put the cube root part, okay? Otherwise your answer is incorrect. Now the other thing that this is helpful for is when you are multiplying radicals. Let me show you what I mean. If you are multiplying, as long as the radicals are in the same type of jail, that is, as long as you have a square root and a square root, you can put them all together. If they're in different jails, we'll tackle that a little bit later, probably in the next section or maybe in the third. So for example, if I had the square root of 8 times the square root of 45, now let's go 72, okay. They're the same jail, but I don't want to multiply 8 and 72, especially and then look for perfect squares in that. So what I'm going to do is I'm going to prime factorize 8 and 72, and then look for pairs because this is square root jail, right? So if I rewrite this as 8 is 2 times 2 times 2, 72 is also 8 times 9, so I could do that. 8 times 9, rather than the 6 times 2 that I was doing previously. It doesn't matter because I'm going to end up with still 3 2s and 2 3s. But now, if I'm looking for pairs of numbers that can get out, so this one gets out, this one gets out, this one gets out, and this one gets out. Oh, it means that we have a perfect square, which brings me to another point. We'll get to that in 1 second. So I have 2 times 2 times 2 times 3, all outside of jail. That's 8 times 3 is 24. So what that means is I had a perfect square. There's nobody left in jail, so I don't need to write jail at all. I just have all the numbers that got out, all right? So that's a lot easier than multiplying 8 times 72 and then looking for the perfect square, which happened to be, in this case, 24 squared, whatever that was. So I'll do one more of those. And again, if it's a cube root jail, then you have to look for 3 of things. Like I could use the same numbers and put them in cube root instead. So if we do cube root of 8 and the cube root of 72, same jail, they're multiplied, okay? Same jail, so I can put everybody in jail together. I'll use the same prime factorization because it's the same numbers. So 8 is 2 times 2 times 2. 72 is 2 times 2 times 2 times 3 times 3, okay? Please notice I still have my cube root here. Now we're looking for sets of 3 numbers in order to get anybody out. So this 2 can break out. These 2 don't. This 2 can break out. Those 2 are gone because remember we're high security. And these 2, there's not enough of them to break a 3 out. So the 2 2s that got out, 2 times 2 is 4. Don't forget it's high security jail, so that's a cube root. And the 3 times 3 is 9. So the other thing that you can add in with this too, and it makes no difference whatsoever, is if I put in variables. So for example, so if I decided to work with 54x to the third y squared, for example. All right, so this is again a perfect square that is square root. So I'm going to prime factorize my 54. So that's 9 times 6. So 9 times 6. All right, and if I wanted, I could prime factorize the x's, prime factorize the y's. And again, I'm looking for pairs of numbers in order to get anybody out, or x's or y's. It's all the same. So for example, this 3 can get out because there's his buddy. These guys don't have any buddies that they can talk to, so they're going to stay in jail. This guy can get out. He's not going to make it. This one will stay in jail because he has no friends. This guy can get out. So where does that leave us? The 3, the x, and the y all got out of jail. It's not high security, it's just regular jail. And who's left? 3 and a 2 and an x. Anybody left inside of jail can also multiply. So it's exactly the same principle. And that's how you prime factorize, and therefore how you simplify radicals, and how you can use simplifying and prime factorizing in order to help you multiply. On the next one, we'll start talking about adding and subtracting like radicals, and I'll review a little bit from grade 10 on that as well. And then we'll go into what happens when you have different kinds of radicals. That is, you have a square root and a cube root. Can we add and subtract them? Can we multiply and divide them? How do we deal with that? So we'll see you soon.